Okay, so today we're going to do scientific notation. So we have scientific notation is a times 10 to the nth power. So I would say go ahead and pause this, let you copy down these examples, and then we'll go ahead and go over them. Okay, so everyone's copied these down. The question says, are the following in scientific notation? So when you're looking here, this is scientific notation. What you want is your A is a decimal. It has to have only one number in front. So let's look at number 1. I have 2.3 times 10 to the negative power 5. It's okay that you have a negative exponent, and looking here you have a decimal and it's in between the first and the two numbers. So this would be a yes. The second one, I have 45.2 times 10 to the 6th power. Here you have 45. You don't want to have two numbers in front of the decimal, so this would be a no because of this here. Number 3 would be a no, 0.23 times 10 to the 3rd power, because your decimal should be in between two numbers. Your first number should not, the number in front of the decimal should not be a 0, so this would be a no. It should look like 2.3. And the last one, 3 times 10 to the negative 2 power. Since there's only one number, the decimal is invisible behind it, so this would be a yes. Okay, so that's telling if it is in scientific notation. The second part is writing the numbers in scientific notation. So right now would be a good time to pause and copy these 6 problems down. Okay, so everyone's copied these down. Let's go ahead and go through them. Writing a number in scientific notation. So you're either going to have a times 10 to the nth power, or you're going to have a times 10 to the negative nth power. So remember your decimal, if you don't see one, it's in the back. So there's a decimal back here. And so what we want to do is count how many times, how many slots we have to move until we get in between the first two numbers. So we would count 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to go ahead and write 1.43 times 10, and since this is a whole number, it's going to be a positive 9. And that is because when I go ahead and write the whole number out, it's going to be a large number. A positive 9 means you're going to go to the right, towards the positive numbers. So in a sense, when you're writing in scientific notation, you're going in the opposite. You're going to the left. So the next one, same thing. I have my decimal back here. I'm going to go ahead and count. I have 1, 2, 3, 4, 5, 6, 7. So I know it's going to be 10 to the 7th power. And then over here I have 2, 3, which is 2.3. So 2.3 times 10 to the 7th power. The next one is different. Number 3 is the opposite of 1 and 2, because number 3 is a decimal. So when I'm finding my decimal, I'm actually moving it to the right. 1, 2, 3, 4, 5. So instead of positive 5, it's actually going to be a negative 5 times. And I've moved it in between the first two numbers, so 3.4. Same thing for number 4. I have a decimal here. My number is a decimal. It's less than 1, so these are less than 1. So I'm going to go ahead and move it 1, 2, 3, 4, 5, 6, 7. I've moved it to behind the 3 because, again, you don't want the 0 to be your number in front of your decimal. So I'm just left with 3 times 10, and I don't remember, it's 1, 2, 3, 4, 5, 6, 7 to the negative 7. So if you're moving your decimal to the left, then your numbers will be positive. It's the opposite, in a sense, of the number line. So think of the number line. Here's a 0. These are your negatives. These are your positives. So if you're moving your decimal to the left, it's actually the opposite. Here we're actually moving our decimal to the right, but our exponent was negative. Alright, number 5. I don't have a decimal, it's here. So I move it 1, 2, 3, 4. If I stop between the 5 and the 6, no. I have to continue on so that my decimal is behind only one digit. So I have 1, 2, 3, 4, 5. It's a positive 5 because it's a number larger than 1. And I'm moving to the left, so in a sense it's the opposite, which is positive. Times, and then it's going to be 4.56. You don't round, you don't drop off any numbers. These are all digits that we have to write. Alright, let's look at the next one. Here, I moved my decimal 1, 2, 3. I've moved it to the right, so it's actually 10 to the negative 3, because this number is less than 1, and it's going to be 7.9. Be a good time to pause if anybody has fallen behind. The next topic is writing, so we're going in the opposite direction. You're given the scientific notation, and we want to write out the number. So go ahead and pause. Everyone copy these examples. Okay, so everyone's copied them. Let's go ahead and look at the first one. The first thing you need to do is you need to find out what number. You need to look at your exponent. It's a positive, so positive means you're going to move your decimal towards the positive. So if I have 5.5, I'm going to move my decimal 3 places. So I'm going to start here. I'm going to count 1, 2, 3. And I'm going to add 2 zeros into those slots. So my answer is 5,500. The next one, 3.2 times 10 to the negative 6. It's a negative 6, so I'm actually going to move my decimal to the left. I have 3.1, and I move it 1, 2, 3, 4, 5, 6. So I add 1, 2, 3, 4, 5 zeros, and my decimal needs to be in front of it. So I'm actually going to go ahead and write a 0 point. I have 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5. Okay, so number 3, again, we're going to go ahead and look and see what number. It's a positive 7, so we're moving our decimal to the right. I have 5.23. So I'm going to go ahead and count 1, 2, 3, 4, 5, 6, 7. Since there's two numbers, you can say 7 minus 2 is 5, so you know you're going to add 5 zeros. And your 52,300,000. Next one, a negative 5. So 4.6. Since we're moving it to the left 5, I move it once, 2, 3, 4, 5. So I'm adding 4 zeros in front of the 4. So I have 0 point, I should have 4 zeros, 4, 6. Next one, negative 4, so again I'm moving to the left. I have 2.09. I'm going to go ahead and move it 1, 2, 3, 4. So I'm adding 3 zeros. When I write this, I copy the 3 zeros and then I make sure I put the 209. You don't round, you don't drop anything. Everything, you need to use all the numbers that are there. And the last one, 3.8 times 10 to the 12th. Positive, so that means I'm moving to the right. And I have 3.8. So if I move it once, then 12 minus 1 is 11. So I'm going to have 11 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I'm not going to rewrite that. So if I start from the back, I can count so I know where to put my commas. So that is going from from scientific notation to a number. And we're not going to worry about this. Okay, so here's your assignments. A14, page 452 through 453. Copy problems and show all work. There are some that have the putting in least greatest. Go ahead and attempt it. Well, nah. Nah. Just skip those. So skip least to greatest. I'll try to find out those exact numbers and let Mr. Toma know. Anyway, go ahead and make sure you do these, show your work. Those of you that are not passing right now, you have F's. It's probably because you're not turning in your work or you're not working all the problems out. You're getting partial credit for trying, so you need to make sure that you're showing work and you're trying all the problems. If you do that, then you're going to get at least 50% of the points. So those of you that have 20% and 40% right now, it's because you're not doing what you need to get done. Anyway, have a good day.